Hello. We have Pre-Calc Lesson 98, Sequence Notations, Advanced Sequence Problems, and the Arithmetic and Geometric Means. We're going to take the arithmetic and geometric means and go a lot deeper into them. Yay! Okay. So, quick review, right? If we have an arithmetic means, the nth term, a sub n, is a sub 1 plus n minus 1d, n being the number of terms that we have. Okay. And the nth term of a geometric sequence is a sub n equals a sub 1 r to the n minus 1. Okay, now for our advanced sequence problems, the common ratio, which is r, can be found by dividing any term by the preceding term. What? Okay, so let's do an example. Okay. If we want to find the 10th term in the geometric progression, that begins x, square root of 2x squared, 2x cubed, dot, dot, dot. Okay, so these are the first three terms of this geometric progression. Now, we know that the 10th term, a sub 10, will be a sub 1 r to the n minus 1, which will be 9. We know a1 is x. Okay, we need to find r. R, you can take any term and divide it by the preceding term. So root 2x squared over x. One of these cancels, gives me root 2x. Okay, now this is my r. I'm going to show you that it's true for my next one. Let's do 2x cubed over root 2x squared. This gives me 2 over root 2x, right? These x's cancel, which if I multiply everything by root 2 over 2, right, this becomes 2 root 2 over 2x, which is root 2x. It works for no matter what you do. So then a sub 10 is a sub 1, which is x, times r, which is root 2x, to the 9th. Now, if I simplify this, okay, I have x to the 1, root 2 to the 9, x to the 9. Root 2 is really 2 to the 1/2 to the 9th power, and then I have x to the 1 plus 9 gives me x to the 10. So this becomes 2 to the 9 over 2, x to the 10. That's my 10th term. Let's do another example. Find the 4th term in the geometric progression that begins 2 plus root 6, 6 plus 2 root 6, 12 plus 6 root 6, and it continues. So we have the first three terms. We want the 4th term. The 4th term, a sub 4, is a sub 1 r to the n minus 1, which we know will be a sub 1 r to the 3. We know that a1 is 2 plus root 6, and we want to find r. So r, we can do 6 plus 2 root 6 divided by 2 plus root 6. Okay, which means I need to multiply by, right, 2 minus root 6 over 2 minus root 6, the conjugate. And if I multiply these on top and on bottom, right, top I will get 12 minus 6 root 6 plus 4 root 6 minus 2 times 6. On bottom, right, we end up getting, if you multiply it out, you'd have 2 times 2, which is 4, minus 2 root 6 plus 2 root 6, which goes away, and then we have minus 6. So if I simplify all of this, it gives me negative 2 root 6 over negative 2, which is just root 6. That's my r. So a4, the fourth term, is a1, which is 2 plus root 6, times my r, which is root 6, cubed. Yay. Okay. So this is one way we could do it. I'm going to show you a little bit of an easier way, right? We know that r is if we divide any two terms, we can get r, right? Which means I can do a4 over a3 and get r, which also means that a4 is r times a3, right? If I solve this for a4. So a4, we don't even have to do any of this. We know that my r term is root 6, and I know that a3 is 12 plus 6 root 6. That's much easier to multiply out than this. And when I do that and distribute, I get 36 plus 12 root 6 is my fourth term. What? Okay, makes it a little bit easier. Okay, let's do a harder problem. A ball is dropped from a height of 81 inches. On each bounce, so it's a bouncing ball, the ball rebounds 2/5 of the distance it fell. How far does the ball fall on its sixth fall? Okay, so this is using geometric sequences. The key, though, is draw a picture. So the first term in our sequence, we're dropping the ball. The ball is dropped 81 inches. It's rebounding up, which is our second one, right? The amount that it is rebounding is 2/5 of 81, which means that's how far it's dropping, is 2/5 times 81. Then we go up again. The third time when it goes down, it's 81 times 2/5 squared, right? Because it's 2/5 of this term. So this is our first term. This next term, we have 81 times 2/5, right? 2/5 of that, which is 2/5 squared. So then we go up again to the fourth one. We go down. We have 81 times 2/5 cubed. We go up again to the fifth one. We go down. 81 times 2/5 to the fourth. Noticing the pattern? We go up to the sixth. We go down. We have 81 times 2/5 to the 5. So on the sixth fall, it's 81 times 2/5 to the 5, which is a sub 6 is a sub 1 times r to the n minus 1. What? And this ends up giving me about 0.83 inches if I round to the nearest hundredth. Okay? So geometric sequences can be used in all areas. This is going to be a new example of a way you're going to get. Now let's go even further. Okay, arithmetic and geometric means. Okay, the means, as we know, are numbers between terms. Right? If we say find two geometric means between A1 and A4. A1 and A4. So the means are the numbers in between our terms. Okay? If we say the mean, then that's just one number. Find the mean between A1 and A3, that's just one number. Now, arithmetic mean is an average. It's an average of two terms. Okay? Whereas geometric mean is a mean proportional. Okay? What that means is it's not the same as an average. Okay? What I'm going to show you through an example. So let's do example 4. Find the arithmetic mean, average of x and y. Right? Arithmetic mean means average. So the average of x and y, we should know what we do, but I'm going to show you in terms of an arithmetic mean. That means my first term is x. That's a 1. The arithmetic mean means I have one more term, which is going to be a2 that I'm looking for, and then I have my third term, which is y, which is a3. Now I remember that a3 is a1 plus 3 minus 1 times d. So a3, which is y, is a1, which is x, plus 2d. So d is y minus x over 2. So then a2 we know is a1 plus 2 minus 1 times d. So a2 is x plus 1 times y minus x over 2. So to combine these into one fraction, I get 2x over 2 plus y minus x over 2, which gives me 2x minus x plus y over 2, which gives me x plus y over 2. That's the arithmetic mean in between x and y. Now, we know that it was going to be that anyway because it's an average. Average, you take two things and you divide it by 2. We knew it was going to be that anyway. But this is also how you do it using the arithmetic means. Now, what about geometric means? Find the geometric mean of x and y. Okay, so again, my first term is x, that's a 1. The geometric mean means I have just one term in between, and my third term is y, that's a 3. Now I know that a3 is a1r to the n minus 1, or 3 minus 1. So a3 is y equals a1 is x times r squared. So r squared is y over x, so r is plus or minus the square root of y over x. Okay, so my second term, a2, is a1r to the 2 minus 1. So a2 is x times plus or minus the square root of y over x. Okay, now I'm going to just leave the plus or minus for just a minute. Okay, so this is x times, this is plus or minus the square root of y over the square root of x. Well, I multiply both the top and the bottom by the square root of x over the square root of x. So I have x times plus or minus the square root of y square root of x over x. The x's cancel, and this becomes plus or minus the square root of yx. That is my a2. Okay? That is what it means when we say a mean proportional. Okay? You don't need to know that that's the mean proportional. Okay? What you do need to know is how to find it. All right. Let's do another example. the positive geometric mean of two numbers is 8. And the difference between the numbers is 30. Find the numbers. Okay, so what does that mean? The positive geometric mean. Well, we know that a geometric mean, right, the geometric mean of x and y was plus or minus the square root of xy, or yx. So the positive mean of my two numbers, I'm going to call them a and b. The positive mean of my two numbers is the square root of a times b, and it gives me 8. Which means my two numbers, a times b, equals 64. And the difference between those two numbers is 30. Which means that if I did, let's do b minus a equals 30. Okay, now I have a system of two equations, two unknowns. So here I can get b is 30 plus a. And I can plug that in here. So I have a times 30 plus a equals 64. So then I have 30a plus a squared is 64. So a squared plus 30a minus 64 equals 0. I can solve using the quadratic formula. So a equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And it ends up giving me that a is negative 2 or 32. Which means I have two possible numbers, right? So if a is negative 2, then b, right, so I'm going to write it as an ordered pair. If a is negative 2, then b would have to be 32. And if a was 32, then b would have to be 2. So the difference between them is 30. So again, we can use geometric means in lots of areas, now using them to solve different equations like this. All right, that is all for today. We will do a lot more practice with this later.